Imagine this, we're about to teleport to the moon. It may sound like science fiction, but what if there's no limit to how far we could go? In a world where the rules of quantum physics continually defy our expectations, teleportation may not be just a fantasy. It could be the future. The realm of quantum physics has long been a place of strange and mind-bending phenomena. From Schrödinger's cat, a thought experiment about a cat that can exist in two states simultaneously, to quantum entanglement, where particles mysteriously communicate faster than the speed of light, quantum mechanics has always pushed the boundaries of imagination. But one idea, in particular, has captured the collective fascination of humanity for decades: quantum teleportation. Once the stuff of Star Trek and other science fiction tales, this concept has ignited dreams of instant transportation across vast distances, whether between planets or galaxies. What if I told you that quantum teleportation is no longer just an abstract idea confined to fictional stories? Dr. Michio Kaku, one of the most celebrated physicists of our time, has made a groundbreaking revelation that could transform everything we thought we knew about space, time, and the very fabric of reality. According to Kaku, quantum teleportation has already been achieved. Now, before you jump to conclusions about teleporting entire cities or human beings, let's start with the basics. What exactly is quantum teleportation? Unlike the teleportation depicted in movies, where physical objects or people are instantly transported across space, quantum teleportation doesn't move matter at all. Instead, it involves the transfer of information using a peculiar phenomenon known as quantum entanglement. To truly grasp this concept, let's dive deeper into quantum entanglement. Albert Einstein famously referred to entanglement as spooky action at a distance, because it seems to defy the laws of classical physics. When two particles become entangled, their quantum states become intricately linked. This means that no matter how far apart the particles are, measuring the state of one particle will instantly reveal the state of the other. It's as though the two particles are in constant communication, regardless of distance, whether they're a few millimeters apart or separated by billions of light years. This strange phenomenon of instantaneous connection forms the foundation of quantum teleportation. Here's where things get really fascinating. Scientists can now use entanglement to transfer the quantum state of a particle to another particle at a distant location, essentially teleporting its information from one place to another. But, and this is key, it's not the particle that's physically transported. Instead, the quantum state of one particle is replicated on another, almost as if creating a perfect copy of the original particle at the destination. For decades, this idea has been theorized, but it's only in recent years that physicists have made substantial strides in turning quantum teleportation from an abstract concept into an experimental reality. Through a series of groundbreaking experiments conducted in laboratories around the world, many in collaboration with prestigious institutions like CERN and NASA, scientists have successfully demonstrated quantum teleportation over increasingly vast distances, with astonishing precision. One of the most exciting achievements in this field occurred when researchers managed to teleport quantum information over a distance of 44 kilometers using fiber optic cables. While this might not seem extraordinary in a world where we're accustomed to sending information globally in the blink of an eye, there's a crucial difference. Quantum teleportation doesn't rely on transmitting signals the conventional way. Rather, it exploits the entanglement of particles themselves to communicate instantaneously, bypassing the usual limitations of speed that govern traditional communication. The implications of this achievement are mind-blowing. Think about a world where data can be sent with absolute security because it's no longer transmitted as physical signals that can be intercepted or hacked. Quantum teleportation could revolutionize the way we think about encryption, creating unbreakable codes that would be virtually impossible to crack. It's a game changer for cybersecurity. An era of unhackable communication could be on the horizon, one where sensitive information shared by governments, businesses, and individuals remains completely secure from prying eyes. But the possibilities don't stop there. Dr. Kaku believes that quantum teleportation could pave the way for something even more revolutionary: the quantum internet. Unlike the internet we rely on today, which uses electromagnetic waves and physical cables to transmit information, a quantum internet would use entangled particles to send data instantaneously, overcoming the limitations of physical distance. Imagine a world where you could communicate with astronauts on Mars in real time, or share data across vast distances without the usual lag that comes with conventional communication networks. These aren't just daydreams, they're becoming increasingly plausible as quantum teleportation continues to progress. Yet, as exhilarating as this may sound, we're still at the tip of the iceberg. The leap from laboratory experiments to practical, widespread applications is enormous. Quantum systems are notoriously delicate, vulnerable to environmental interference, and maintaining the entanglement of particles over long distances is a major challenge. But despite these hurdles, progress is happening at an astonishing rate. For example, in China, researchers have made incredible strides by using quantum satellites to demonstrate entanglement and teleportation over distances exceeding 1,200 kilometers. This achievement has proven that quantum teleportation is not limited to fiber optic cables in controlled lab environments. It can function in space, opening up the possibility of interplanetary communication and even quantum-powered space exploration. Kaku is optimistic that these developments are only the beginning. He envisions a future where quantum teleportation is as ubiquitous as Wi-Fi. However, while the promise of a quantum-powered future is exhilarating, it also raises profound philosophical questions. If we can teleport the quantum state of a particle, what happens when we scale that up to larger systems? Could we one day teleport molecules, or even living organisms? And if we were able to teleport a person, would the teleported version be the exact same person, or simply a perfect replica? These are not just idle questions. They touch on the very essence of what it means to be alive and conscious. If quantum teleportation were applied to humans, would the person on the other end be the same individual, or would they simply be a duplicate, with their memories and consciousness transferred, but the original person left behind? Dr. Kaku speculates that while human teleportation may one day be technically possible, it would require a deep understanding of consciousness and the human mind far beyond what we currently possess. In the meantime, quantum teleportation is already poised to revolutionize fields like computing. Quantum computers, which harness the principles of quantum mechanics to process information in fundamentally different ways than classical computers, could be connected via quantum networks to communicate in ways that are impossible with today's technology. This could create a global network of quantum-powered intelligence, capable of solving complex problems across fields like medicine, climate science, and artificial intelligence. Of course, with any transformative technology, there's the question of who controls it. The potential for misuse of quantum teleportation is significant. With the ability to send information securely across vast distances, nations and organizations could leverage this technology for surveillance, control, and potentially even new forms of weaponry. The prospect of a quantum arms race is not out of the realm of possibility, underscoring the importance of international collaboration and regulation in the development of this groundbreaking technology. Yet, amid the promises and risks, quantum teleportation could also hold solutions to some of humanity's greatest challenges. It could transform the medical field, enabling the secure transmission of sensitive patient data, or even facilitating breakthroughs in diagnostics and treatments. It could help tackle climate change, optimizing energy grids, and enhancing resource efficiency. As we explore the boundless possibilities of quantum teleportation, we must also confront its ethical and philosophical implications. What does it mean for something to be real if only its information is transmitted, but not its physical substance? The questions quantum teleportation raises about the nature of existence and identity are deeply philosophical. If we could teleport a human being, would they be the same person, or merely a perfect copy? These questions challenge everything we know about the self, consciousness, and what it means to exist. They force us to reconsider our place in the universe. For Dr. Kaku, quantum teleportation is just the beginning of a future where humanity transcends its current limitations. He envisions a world where we use the power of quantum mechanics to explore the cosmos, solve the mysteries of life, and unlock the untapped potential of the human mind. But this future is not inevitable. It will require unprecedented collaboration, innovation, and ethical stewardship. We must confront our fears, embrace the unknown, and ask ourselves what kind of world we want to create with these revolutionary new technologies. As we stand on the edge of a quantum revolution, it's clear that quantum teleportation is more than just a scientific breakthrough, it's a paradigm shift. It will reshape how we understand reality itself and challenge the very fabric of our existence. The journey into the quantum realm is just beginning, and the discoveries made today will define the course of human history for generations to come. As we unlock the secrets of the universe, we may find that the greatest mystery of all is not out there among the stars, but within ourselves.